problems with different tension, right? We did one with these, right? This one, and the one was 5.B, right?
5.7B.
5.7B, which was a little bit tricky because this angle was given, right? This was this was 60, and then your mass was hanging here, and there was another 45, something like this, right? Isn't it? So this one was 45. Actually, it doesn't look like 45. So anyway, something like that. Oh, it doesn't look straight anyway. Okay, a little bit like this. So here, the point here is all you have to do is find total. So this one tension, this one tension. All you do is
And the angle.
get the x. So this is 45. This one will be 45, right? And this one, if this is 30, this is 60, then this will be 30, isn't it? So now all you do is get tension. This is your tension 1. This is your tension 2. So tension 1 cosine 45, right? Will be along x direction. This one will be tension 2 cosine of 30, right? But with the negative, right? It's on the negative direction. Makes sense? So actually, in reality, it will be 180 plus 30, isn't it? That's why it comes negative. That will be same as cosine of 30. You don't need to do 180 plus 30. Okay? All you do is just take cosine of 30, and then since on the left, just use minus sign. Okay? Alright, you can do that way. Because now you are used to with the direction, isn't it? And then similarly, y, you take the component this one also, right, vertically. So you just take it sine of 30 and put negative sign, alright. Either way, it will be same as 180 plus 30. Sine of 180 plus 30 will be same as sine of minus 30, isn't it? So in either way, it will be negative sign. So, and then the bottom line here is total of force along x will be 0 and total of force along y will be 0. All you do is equate this, right? That's in nutshell what we did in the last class, isn't it? And we did a couple of problems with the elevator going up and down, right? Right? Or the string, we have one string there, and tension here and tension here. If the string also has mass, isn't it? Then at this point we have this mass going down and this going down, right? And all those things. And then the elevator, we did the elevator problem, which the normal reaction, which is normal reaction means what? The normal force of your scale. We did like, let's assume we have a scale on an elevator, and the elevator going down, what the scale will read, right? And if the elevator goes up with an acceleration, of course, if it goes with a constant speed, what happens?
It is the same.
It will be the same, right? In other words, your normal reaction will be same as mass times gravity if there is no acceleration, isn't it? Whether it is at rest or constant velocity, right? Your n will be mass times gravity. So these are the things we did in the last class, and we did a couple of problems. What we're going to do today is we did a little bit about friction. All right. So now, friction. Friction is if a box is lying on a surface, on a table, when you push it, look here, like I'm pushing this, I'm pushing it, right? I'm pushing it, it's not moving, right? What it means is, if I push with 1 Newton, this guy, the surface also pushes me back with 1 Newton. Exactly 1 Newton, not more, not less. Are you following? That's why your net force is 0. Make sense? Because it's not moving. It's not moving means the total force must be 0. Period. Right? So if I'm pushing, I'm pushing it with 1 Newton, 2 Newton, I keep on increasing, still it's not moving. So what it means is, the force applied is directly proportional to the frictional force. Means if I am 1, he is also 1, and the friction is also 1. If I am 2, friction is also 2. Make sense? Whatever I apply, friction will be the same thing. A time comes if I keep on increasing, a time comes when my force exceeds to certain value which this guy cannot apply. Are you following? And then it starts moving. Make sense? So there is, what happens here is, if I draw a graph, let's say this side is my force, I call it force applied, alright, and this guy, this side, I call it frictional force, F of friction, friction, friction on this side. Then if I put 1, the guy will also put 1. If I am 2, that is also 2. Are you following? If I am 3, that guy also goes 3. Exactly same. Keeps on going up to a certain limit. After that, let's say I apply 50 Newton. That can, the maximum it can push is 50 Newton. Then if I apply 51, then the body moves. Are you following? As soon as I cross that limit, certain limit, then it starts moving. And when it starts moving, what happens all of a sudden is this one is called static friction. Static friction means it's not moving. Alright? I keep on increasing, but it's not moving. Make sense? But after a certain time, I call it, this one is max static friction. I call it Fs. Alright? Max of Fs. Static friction means I call it F of S. Okay? So after this time, what happens is the body no more remains at rest, isn't it? So now it starts moving, right? So when it starts moving, I call it kinetic. So in that case, remember, sometimes, I don't know, if your car breaks down, right? And you need to like push to the curb, right? Initially you need more force. 1, 2, 3, keep pushing, and then once it starts, and then it's easy to move. Are you following? So first you may need like 2 people. So one starts moving, right? One starts moving, and then only one alone can push, right? Are you following? So in other words, your static friction is higher. But once it is in motion, now the friction force opposing your force, friction force is the force that opposes your force, right? Are you following? The force that opposes your will be smaller than this thing. So after that, it's only like this. So once you start moving it, now it has a certain limited kinetic friction, right? And you have to apply the same amount of friction, because once it's already in motion, already has a certain velocity, right? Which keeps on going with the same velocity at this point. So this one I call it kinetic. This one I call it kinetic friction. Alright? So kinetic friction means what? What it means is, once the body starts moving, now the friction is a little bit less than the peak friction. Make sense? Now what happens here is, I don't want to go into detail about the molecular structure, what happens there in the surface of contact, the molecule, there are so many things there. But let's go directly to the physics part. Alright? What happens is, this frictional force, this one I call it now F of kinetic. This is the frictional force, but excuse me, the kinetic one. Now, excuse me, experimentally, the frictional force, which is basically opposing force, if you are pushing this way, your applied force, I call it applied force applied, then this green one will be Fk, which always opposite, right? So once it is in motion, again those two are same. It's a different story that your kinetic friction will be less, that's why your applied friction will also be less, right? Right? Okay. So now, your force, your frictional force, whether you call it static or kinetic, either one. So let's take the first one. I take it Fs, which is static friction. Alright? which is that peak friction. I'm taking only the peak friction, okay? I'm not dealing here, I'm going only here. This is found to be proportional to the normal reaction. I'm not going into detail again, alright? What is normal reaction? What is normal reaction?
The force is like
The force going up, right? Which will be equal to what?
To the
to the force.
To the force of to the weight of gravity, right? Very good. Which will equal to W. So this one is N will be equal to W if it's not moving in the vertical direction, right? If it moves, then there will be another story, right? Now this is proportional to N. So if you remove the proportionality, this thing you have to introduce one constant, which generally you call it mu of K. Mu of, since it's S, which is mu of S, static friction, times N. Are you following? If it is the kinetic part, then your F of K is mu of kinetic of N. Now, can you tell me which one will be greater, mu K or mu S? Which one you think is greater?
I think S.
Mu S, right?
Yeah,
Because this, which one is greater than these two?
I mean Fs is greater.
Fs is greater, right?
Yeah.
Are you following? Fs is greater than Fk. Make sense? So what it means is your mu S. Okay, let me write it here. Your mu S is equal to Fs divided by N, right? F of S divided by N. Mu of K is also same thing. Mu of K is also same thing. F of K divided by N. Is that right? But the question here is what? N is same thing. N equals to mass times gravity, at least in this case. Isn't it? In this case, N is same thing. But Fs is more than Fk. Right? So it is obvious that mu S is more than mu K. So in other words, the coefficient of friction, the static friction is higher than the kinetic friction. That is the coefficient. Coefficient is like a property of the surface. Okay, it's a constant, and it doesn't have. What's the unit of mu, by the way? Can you tell me the unit of mu? It has no unit, right? Because what? Your force is Newton. Normal reaction is what?
It's Newton.
It's Newton.
Yeah.
Why is taking this time to say Newton? Come on. Right? So both are Newton, so they will cancel. So basically mu, or the coefficient of friction, doesn't have any unit. It's a unitless number. Right? It's just the ratio. And it depends on the surface of contact. Are you following? So some has low, some has high. For example, like a smooth surface has low mu. Alright? A rough surface has high mu. Because smooth surface you need very less force. Isn't it? Yes.
Is the reason why mu is larger is because it takes more energy to start moving an object than
Use more
to,
force
than
rather
to keep it
Yes.
moving?
Yes. Yes. It's more force, not energy. Well, kind of it relates to energy because energy is force times distance. So, your more force means if you have the same distance, so more force means more energy, kind of, right? Or more work done. It's almost similar. But the point here is static is more friction, right? Static friction has more force. That's the reason why the coefficient of static friction is high. Alright? And the coefficient of kinetic friction is lower. Let me do one example. Okay? Let me do one example. So what I do here is I leave this. By the way, if you draw a free body diagram, what usually you do is, even if you push here, when you draw a free body diagram, it will be something like this. Because this is pushing means you have to start with the origin and then here like this, right? You have to start it here, right? You cannot draw it like this. isn't it? So your FA is this, your FA is this, I'm using the same ink, it's okay. So your F of applied is this, F of K is this, W is this, N is this, right? Right? So when you see this, there's a constant force here. Look at, if you take the resultant of these two, right? The result will be what? It's like somewhere here, right? Constant force. This is basically just like the sum of these two which goes this side. Either way, if you get the total, it will be 0. Are you following? Right? So as long as it is at rest or moving with a constant speed. Alright? So let me do one quick example. Let's have a very simple example in which there is a body, there's a block on a surface, and you apply, it's like a car, alright, and you apply a force, give me a number, something. 20, maybe 100 Newton, let's make it 100 Newton. 20 is okay, just a number, alright? And let's say this guy has mass 20, okay, I'll take your number, I don't want to embarrass you, okay? I'll take your number, okay, 20 kilogram, okay? So now, okay, let's say mass is 20 kilogram. You apply 100 Newton force. Initially you need 100 Newton force, alright, to make it move. Are you with me? Are you with me?
Mm-hmm.
So now, what happens is, here it applies certain force, of course, right? Unless you reach 100, it doesn't move. Are you following? So if I write a question something like this, what is this, card or something, card or block, right? Starts or initially, how do you write it? Just write in your own language. A block starts to move when the force is 100 Newton, right?
Is applied.
Is applied. You push.
Cars
Right.
Car starts to move at 100 meters.
And 100 Newton of applied force. You use our language. A car starts to move
A cast stance. So
when applied force is 100 Newton.
Okay.
Alright? Alright? Applied force is 100 Newton. Let's say. A card of mass 20. I forgot this guy. Card of mass 20 kilogram, let's say. Alright? A card of mass 20 kilogram starts to move when your applied force is 100 Newton. Once in motion, you need only what? You need Fk, once in motion, you need, not Fk, actually, you need your applied force on, how do I write it? FAS and FAK, okay? Alright. Fk represents for the kinetic friction force, not for applied force. So applied static force, and this is applied kinetic force. Alright? Alright? Applied kinetic force will be less, so it's only like, let's say 80 Newton. Once it's in motion. Yes.
when an object's at rest on a surface, is there still static friction?
Yes.
Or is it just acting in all directions?
Yes. Yes. But the static friction comes into play only when there is external applied force. Alright? If you don't have external applied force, then then it doesn't come into here. So it's still there. It's like a 0. Alright? It's a 0 or in all directions. Alright? Because all direction means the total will be 0. Yeah. Okay. So now what you do?
What is the question?
So find the statics, find the coefficient of static and kinetic friction. What do you do?
Find the normal.
Draw first of all a free body diagram. Alright? Yes.
So you will put 100 minus the
Right, FAS.
FAS
Uh-huh.
equals MA plus.
And A, but there is no A. It's moving in the, starts means the peak static rest. Starts means
Okay.
just start. Right? Just starts to move. Oops. Just start to move.
So acceleration is constant then?
Acceleration is 0, not constant.
Yeah.
Velocity is constant. Well, in this case, just start to move means still at rest. The peak rest. That's the static friction. Remember the graph? Remember the graph is here. Where was it? Right here.
Yeah.
This one. Still it's not moving, but just starting to move at this point, which is Fs. Static friction force. The big one. So now how you draw the free body diagram? How you draw
So
this?
you have the force that's coming to the right, that is 100, and you have.
So this one is this 100, right?
And then you have the
F
friction
of, I
force.
call it what? A of S equals to 100, is that right?
And then you
Yeah.
have friction.
And then there must be some friction force, which I don't know for now. I just write here Fs.
But it must.
It
Uh,
must,
equal
well,
to 0.
it will be equal, yes. The total will be 0.
So you will find it by the friction force. So 100 minus the
Right.
friction force, and then that will be mu k.
Right. Let me finish drawing first.
Which is
And downward will be what? Your weight,
That's the normal force.
is that right? Weight.
And then the normal force.
And then there will be normal force, right? And then up will be normal force. So first get all the x and y. Just do this. Easy. X, y. Right? Your total force along S must be 0, right? Right? What is the total force along X?
So,
F of AS plus minus Fs, right?
mine.
Is that right? So what it means is your F of S equals to F of AS. F of AS is given there 100. So basically your Fs is also 100 Newton. Is that right? Is that right? So on this side you find your N. On this side, total of force along Y is also 0. So what is here? N plus minus W, right? Because W is going down, right? W is mass times gravity, so N goes on the right, so W is mass times gravity. So this will be, what is it? 20 times 9.8. Remember, this is the magnitude. Alright? This is the magnitude, because the direction is already taken care by this guy. If you put minus, then it's already taken care. So your last question I still remember. Why don't you put minus there? So if you put minus there, then don't use minus here. You cannot do minus and then again minus. Alright? Okay, so this one will be what? 2 times 8, 16, 9, 196 Newton. Right? Right? So now, what's your mu? S. Mu S, what's the formula for mu S? Go back there. Which is F of S divided by
divided by N.
divided by N. Right?
Yeah.
So what is this? 196 Newton divided by, 100 divided by 196 Newton.
1.96.
So this is? No, it cannot be 1 point. Come on. It cannot be more than 1. By the way, one clue.
0. Yeah.
What is it?
0.5.
0.51.
51.
Okay, 0.51 mu s. How about find mu k? Now go to the kinetic one. Kinetic means what? Let me draw the free body diagram for kinetic one. So kinetic is again the same thing here. N W. This one will be f of k, and this one will be f of a k. Is that right? Is that right? So now, but now this one is what? F of a k is only 80. Same thing. Same thing. What happens now? What happens now?
So 80 divided by 196.
Everything is same. S goes to K, right?
And the FK gonna be.
Static goes to kinetic.
FK gonna be 80.
Say it again.
FK gonna be 80.
Yes. Now this guy will be Fk. This guy will be same, isn't it? The y is same. There is no change in y. But x there will be a change in value. So
Maybe 80 over 196.
okay, so only in case of x there will be a change. Oh, red pen. Okay. Only in term in case of x it will be changed. So f of a k plus minus f of k will be 0. So f of k will be f of a k, which is what?
1.
F of k is 80, right?
Yeah.
80 Newton. Therefore, mu of k will be f of k divided by
N.
n. So this f of k is 80 Newton divided by n is what is it?
0.41.
0. No, n is what?
196.
196. 196 Newton. So this will give what?
0.41.
0.41. So can you see here? The static friction is greater than
Then that can end.
the kinetic friction. Are you following? Static friction is always greater than kinetic friction. How about, now I change a little bit. Okay. What I do now is, instead of pushing it horizontal, I want to push it because my box is small.
Upward.
No, I'm pushing it downward, like at an angle. Now the condition here is, now what I do is same thing, same box. Instead of pushing it horizontally, now I am pushing it this way. Are you with me? Now I change the question. Remember, if I push it this way, same box. Let me make the same box. Okay? Same box means what? Kinetic friction is this. Same box means the same surface. Alright? Coefficient will be same. This is same. Now the question is, what must be the applied force? This is a total new question. What must be the applied force so that the same box moves with a constant velocity. Are you following? Are you following? Find the force required. Make sense? Find the force required so that the box moves with the same velocity. So, if I want to rewrite the same question, by the way, if I push it this way, means I have to apply some angle there. Instead of pushing it horizontal, now I am pushing it at 45 degree or something. Let's say 45 degree.
Because it'll be moving in a constant velocity. Okay.
Are you following? Make sense? Now what you do? Now the condition is, the question here is, applied force is Fa, you need to find out. You need to find out what is the applied force. When your angle with the horizontal, remember that's an important question. You must have like at what angle? Is the difference between pushing it like this or pushing it like this? Pushing it this way or this way or this way? It's different. Are you following? So now, if your theta is 45, make it 40. Don't make it exactly middle. Okay, let's make it different. Make it 40. Because 45 is exactly middle, isn't it? The value of sine and cosine will be same.
Would it be 40 Newton?
No, angle 40 degree. Angle cannot be Newton.
No, 40 newtons. No?
40 newtons?
Yeah.
What do you mean 40 newtons?
The answer.
Oh, you are already in the answer. Oh, okay, wait. Hold on. So let's do it. Alright, let's do slowly, step by step.
Oh, wait.
So here you need this, and the surface is same thing. I use the same mu k.